First of all, let me introduce a little bit who we are. My name is Sameh Yamany. I'm the CTO of VIAVI Solutions. Some of you may know us from before. We used to be called JDSU. We're actually, in 2 years ago, we celebrated being 100 years old. So we are 102 years old right now. And we are very specialized mostly in test and measurement. So when the rubber meets the road, when you really need to know if things works or not, or when it doesn't work, why it's not working, probably we are involved in a lot of these activities. So, you know, when we celebrated 100 years old, I was actually had to give a speech saying what we think is going to happen, not the next 100 years, but let's talk about the next 5, 6, 7 years, right? So I'll talk a little bit about the vision that we have seen, especially in our areas. We are more focused with the telco, and I think that the expansion of that and how AI is changing telco, and I think not just it's changing it, I don't think telcos can survive without actually using AI. So we see, you know, these 5 different areas of trend that's gonna actually change how the telco domain is gonna look like. One, which we are here in this conference, optics and photonics is expanding. You know, I mean, you know, we are involved in a lot of the fiber installation, fiber testing, and fiber optimization, but you know, it's going beyond that. Right now, actually, our biggest, user of our tools are actually the AI data centers. They are, you know, adding more fiber than the telco in the last, 10 years. So this is expanding. You know, the data centers are becoming cities. So not only, communication between the data centers themselves, inside the data centers, inside the actual server, and now we're talking about photonic computing, where the technology of photonics is moving all the way to the end device. And definitely, one of the areas we are also seeing photonic is going to make a big impact, and I'm going to talk about this at the end, is in quantum computing, and I'm happy that ION already has some now work groups for photonic computing, for quantum computing and quantum comms, because again, this is a thread that needs to be fixed immediately to actually manage the next security with our communication. The second one is wireless. Of course, wireless, we have been in wireless since the beginning. Wireless is expanding. Yes, 5G didn't deliver exactly on what we are looking for. Then there was this whole discussion about openness and Open RAN, but the evolution is going on. 6G and beyond, I'm gonna talk a little bit how AI is gonna be native and essential for 6G to actually provide the benefits that maybe 5G didn't actually do. We are also seeing expansions in the non-terrestrial network, with terrestrial network. One statistics I just saw a couple of weeks ago is that 96% of operators around the world actually do have an NTN plan. So that's not any more kind of a wishful thinking. It's going on. Now there is still a lot of problems with NTN, and I'm gonna talk about that. And then the evolution of RAN, the AI RAN. This is what we have been hearing about, how AI is gonna fundamentally change the way we think about building the network bottom up, right? And that includes private network. And I also looked at positioning, navigation, and timing with a lot of what's happening in the world right now, with a lot of these areas where jamming and things happening, positioning, navigation, and timing becomes a very important topic. I'm gonna move to the last one, sensing, because there is also, we are using Face ID, all of us, this 3D sensing. By the way, VIAVI is providing a lot of technology in the 3D sensing. Fiber sensing is actually, we are seeing now being used. So fiber not only used for communication, but for a lot of these sensing capabilities that is helping in different use cases. But more and more, what we're seeing the next generation of sensing is using the actual telecom network for sensing. There is this new innovation coming in, integrated sensing and communication, ISAC, which is going to be one of the components of 6G. So that's also one of the trends we're going to see, how the network is going to actually be used as a sensor, not just as communication. And that AI becomes a very essential part, because as we're going to see the complexity, and I think we have seen in a lot of the different presentations so far and the last 2 days, automation is key, right? And AI is going to play a very important role in automation, not just for optimization, not just providing a lot of the ops using AI, like replacing all the OSS and BSS with AI agents, but actually, believe it or not, in field ops itself, the complexity and the training of new field ops to actually build a new layer of generation of network is becoming really hard. And AI is going to play a very important role in kind of assisting this kind of field deployments. And I'm going to spend a big portion also on the digital twin, because we come from the area of simulation. A lot of you are using our tools for simulation in the lab and so on. But simulation has to change, because in many cases you build the thing in the lab, and the moment you put it in the field, it doesn't work. And they will say, well, what did you do in the simulation, right? So this concept of bringing the data that is real and then using Gen AI to actually build realistic scenarios that you're not simulating, like a flight simulator, you're actually building a real network, and then you're actually testing against this real network. So I'll spend a little bit more time on that. One topic that is also very, important for me is that we're gonna, we are agreeing AI is gonna be everywhere. It's gonna be embedded. It's gonna be making decision on the network, which is critical infrastructure, by the way, for a lot of governments. Who's testing this AI? And how are you gonna test this AI? And I think argue that AI has to test the AI, right? It's not, we have this saying, don't go to a gunfight with a knife, right? You really need to know how to build guardrails for the AI. You have to use AI. And this brings me to a very important piece that I'm going to spend a lot of time on presentation is AI is not going to be effective unless you have the right data governance. And how you get the data that you're going to train the AI and also use this data during dynamic behavior of this AI becomes a really important thing. And of course, of all of this, cloud native is going to be essential for that. And also the business model that's going to come from that is going to expand. We do build a lot of labs around the world, but now we're starting doing something different. We're building lab as a service, right? Like using cloud technology to provide the same thing you have in a physical lab, but actually using it over cloud. So let me start by the first thing is that who are we building the network for? Traditionally, network will focus on voice, data, and so on, but we're seeing right now that the actual consumer of the network is a different kind of vertical applications, right? From autonomous driving becoming really important, and network is going to actually enable a lot of capabilities in this autonomous driving, and that requires sometimes requirements that it's orthogonal to what you used to do in data and text. I mean, this is vehicle to vehicle, vehicle to infrastructures. You have to build kind of latency application that can manage these kind of application. I give another example. We also work in aviation. There was a lot of things that aviation today needs. A lot of airports are modernizing the way they are doing the automating there. And again, 5G and 6G is going to play a very important role, and that becomes a different kind of user for this network, right? And for doing that, the concept of digital twin becomes important. Why? Because now you start thinking how I'm going to actually do a lot of these optimization, how I'm going to, we know that spectrum is going to becoming important. We know that the environment has to be, energy efficiency, spectrum efficiency. So digital twin will help you design for that. So, like we're saying AI is going to change, coding. Also, AI is going to change the way you design networks, right? You have to use them using digital twins. A lot of applications can depend on these digital twins. A lot of innovations, a lot of research now is using digital twin to fix some of the challenging problems that we are seeing in telecommunication. In fact, I argue that AI itself is going to be now used to solve some of these problems themselves, right? And of course, as I said, network planning and design with digital twin is going to completely change, right? Traditionally, you build the network, you test it, and then you go in and deploy it, find problems, you go back again, and this manual process takes a lot of time. That's why, moving from one technology to another used to take years. With a digital twin, this is something that can actually be dynamic, and I will give you some examples for that. So how digital twin works? For us, it's a simple thing. One, you really need the data. You really need the field data. Either this data coming from the network itself, these data, there are a lot of field instruments out there that produces a lot of these data. So the number one thing is where you're going to get the data from. And then you use this to train the traditional emulation and simulation model that was already there. So you're not using synthetic data, you're actually using real data, and this cycle creates for you the concept of the digital twin itself. So it's not just synthetic data, not just imaginative data, this actually using real data continuously. So as the network evolves, your digital twin evolves with it as well. So one example, for example, for the AI RAN, we're using right now a lot of the 5G data. So the idea is to build a new simulation of how, let's say you're going to have drones and you're going to have emergency services, how the network is going to adapt to that. And the idea is to use this kind of RAN scenario generation, use AI tools to get real data from the field, real data from a lot of what's out there, even crowdsourcing data, and use that to actually generate these kind of AI RSG. And once you have this digital twin, the RAN scenario generation, now you can build a lot of application on top of that. If you want to do SON, if you want to do near real-time RIC, all of that now can, instead of connecting it to a real network and do this, you actually can connect it to this kind of a digital twin or RAN scenario generation, and now you can innovate on top of that. You can test different scenarios, you can build applications for that, right? The other thing is, examples of today applications for this kind of digital twin. So we're working with one of the largest ports in the world, right? I'm not gonna mention, but where they have actually a ship coming to the port every minute, right? This is becoming really hard. So digital twin in this case is gonna emulate a lot of these physical and network assets. What is the new chip arrival? If you're gonna have to have drone employments, you have to have some kind of bandwidth shift. And we test this in the digital twin first, before they can actually apply it in the port, right? And then you build on top of that predictive model. What's gonna happen if you're gonna have many ships that's coming at the same time, or what's gonna happen if, there is a delay, right? These kind of decision right now is really hard with the complexity of some of these ships. I said the ship coming every minute. So a digital twin can help, in this decision making. Not completely, but at least providing some kind of assistance. That's what if scenarios. What if, for example, at this moment, we're getting, a typhoon, or we're getting a hurricane, or there are some weather changes. You can also apply this inside the digital twin and see how you can mitigate that and how you can build resilience for that. The other thing is really hard is that a lot of these port authority, when a ship comes in, they actually can, they don't let the pilot do it because it's of complexity. So they either had to, have their own pilot, or in many cases they do remote piloting. Now, remote piloting is a solution if you have the actual coverage that doesn't change. So, in these scenarios, we're looking at putting antennas and putting different capabilities on actually barges that's moving around in dynamic form, so that you can actually create a coverage scenario that is dynamic, that is covering the current scenario that you are in right now. Again, these kind of activities is help with this assistant of this digital twin. And if you think about this digital twin, is data is collected and an AI engine that is continuously creating these kind of scenarios. Another example is all this idea of building new apps. These apps and these verticals require a network. Now, if you want to test it on a critical infrastructure, a lot of the operators say, well, I'm sorry, I'm not going to open my APIs for you to test the app. But we can do this with a digital twin, exactly similar to a big network like an AT&T or an NTT Docomo or Singtel, and you can actually now expose the APIs to the digital twin for the application developments. And these APIs can allow you not only to get data from the network, but it will emulate what the network is going to behave if your app is doing 1, 2, 3, 4, right? So this is another example of where digital twins can help in the development of new applications, right? It's a sandbox environment for the developers, so you don't have to worry about the critical infrastructure, but it's also not a cartoonish network. It's actually real network. It has this real behavior of an actual, at a high scale network as well. And then, of course, once these developers are doing this, can be a marketplace for them to actually advertise their applications. And then, one of the examples we're also doing right now in the US here was smart agriculture. Very complicated things where you have drones, you have these tractors that have cameras that's using AI, they're using satellites, and again, how are you going to design this? A lot of the people who are building these kind of tools have no actual experience in telecoms and the network design. So a digital twin can help integrators and other vertical providers to actually do all of this, design it, and then test it before you actually put it in the field. So this is the example. Actually, VIAVI also, we involved a lot in railway. I don't know, a lot of you know in Europe, for example, railway is still using 2G network. They are moving to 5G. But one of the problems is how are you going to test that? You know, there is a lot of complexity right now between not just the telecom, but train-to-train signaling with the network itself, with the different part of the network. So we are actually helping a lot of these upgrades right now, also using digital twin, collecting data from the network and building scenario generation for them to do what-if scenario, how you're going to actually have different policies to manage this example. So this is one around the digital twin. Now let's talk about the next generation network as well. NTN is a very big thing, right? If you look at where they are seeing, there is a lot of different market for NTN. Smartphone and wearables, but also vertical markets, utility, agriculture, as we talked about, emergency services. All of them requires 100% guaranteed coverage and autonomy and security. So, there is also enterprise that looking for integrated terrestrial and non-terrestrial network, rural areas. I mean, these are all applications today that, that will benefit from the NTN. But the NTN has still a lot of, problems. You have the station that is in the orbit. Are you going to put the G node B in the satellites? What we call it a transparent, or is it going to be in the ground? There is still a lot of problems in designing how you have device to satellites. Mobility. Doppler effect. So there is so many things that you really need to do. So what we are also helping here is building this NTN digital twin as well, where you can actually do a complete simulation. And you design it based on, is it LEO or a MEO or a GEO? And we actually can emulate based on actual movement of satellites constellation, what will be your solution to, for example, something like Doppler shift, or what would be the latency if you do X, Y, Z, right? So this, again, digital twin can help fix some of the problems today with NTN. We also use real data from the NTN, from the 5G network to actually do kind of simulation models that is more realistic for the network behavior, network ingestion, and the traffic simulation. And of course, you can build a lot of protocol performance validation. You do predictive analytics using the AI model for beam handover, for example, prediction. So this is a tool today that is being used by a lot of NTN researchers, a lot of vendors that are trying to build the next solution for NTN. And then, of course, the biggest thing that we are seeing, AI is going to change in telco with 6G, the AI RAN, how AI is going to become native in the radio access network. And I argue that there is a lot of things that we can do for the AI RAN. Of course, building digital twin, looking at bringing field data into the lab, AI, testing AI. But the most important thing, what we call data for AI, that for actually making the RAN behave the way we want, we have to have the right data to train this AI, and also the right data to test this RAN, right? So, one of the things we do today is that we are using a lot of the data that we collect from the network to actually do a lot of these predictions, looking at beamforming, how AI is going to behave. You can actually test it in different scenarios, and you can see, for example, the heat map based on some of the coverage scenarios, some of the AI algorithm, so you can actually see it in 3D models using real data from the field. Actually, this is done here in Dallas, if some of you are familiar with the Dallas streets, right? So these are the kind of things that also AI is going to change in the network itself, right? And then, of course, here is the big thing, and I was trying to build this over time. The network of the future is going to look like this. It's going to be literally all of these different components coming together, software, hard, and AI, so that when you want to have a new vertical, the network can dynamically actually create the slice for you. That's the holy grail. That's what you want to do. Like, you actually be able to be adaptive to different applications, different scenarios, by actually managing this using an AI engine. That's this agentic AI. Now that the network has all these capabilities, all these APIs, you will be able to create these slices, not based on human, but actually based on a network that is self-healing, on a network that is self-adapting, that's using the AI natively, so that you can build that, right? So we are today building, using this AI, a 6G test bed that can actually have a lot of these capabilities: AI-powered digital twin, integrating field with lab, bringing AI native beam and channel emulation, and also building these kind of over the air and all of these kind of simulations. So that's one. The other one is important is, deployment itself will require digital twin. The discussion about neo cloud, where you have the cloud very close to where the installation is or where the actual site is. This is also can be a place where the digital twin can be placed inside, actually next to where you are deploying. And of course, testing and verification becomes really important. Not just testing performance, testing power, efficiency, spectrum efficiency, all of that becomes part of it. And then of course the application that's going to run of that, either open APN, 6G NTN, quantum safe, spectrum efficiency, or ISAC applications, right? The last thing I'm going to talk about, so this is the kind of what we are having, and ISAC is a key technology right now that is being talked about in 6G. This is where sensing becomes, the network becomes a sensor, right? Especially for drone detection, for UAV detection, for a lot of applications that cannot be done by normal radar sensing technology. So there is a lot of discussion there, but again, AI plays a very important role there, where you can use some of the data that you have to actually be able to build localization, tracking, smart resource allocation. These are all part of what we call the ISAC, integrated communication and sensing testing itself. Now, the last thing I'm going to talk about is, is quantum, comms, right? Which also is photonic. I mean, the whole idea of quantum key distribution is using this kind of photonic, and quantum entanglement to actually build these kind of keys. Now, it is, in many cases, what happens is that you have a lot of these QKD, devices out there. The moment you install them, fiber technology is still not there to meet the demand. So there is a lot of things that's going on, and we are working with a lot of vendors and providers, telecoms, to actually solve a lot of these different problems, like understanding the urban fiber noise, environmental fluctuation that can impact some of these quantum key distribution. So this is another area for that. And of course, the last thing is post-quantum cryptography, where again AI plays a very important role in testing a lot of these algorithms, creating scenario to see are they going to be resilient to quantum computing or not. So with that, I hope I give you a little bit of taste of where we are seeing the trend, especially in our part of the telco network, and I hope this opens a lot of discussion. Thank you so much.